Alrighty, we are going to start solving equations that we haven't been able to solve before except through guess and check. And it's going to require us to use logs because when you're solving, the way you get rid of adding is to subtract. The way you get rid of multiplying is to divide. You square root to get rid of squares. And to get rid of exponentials, you're going to rewrite it as a log. So one thing you're going to find yourself having to do is find these values on your calculator. And so we're going to talk about something real quick called the change of base formula. Some of you will have graphing calculators and you'll be able to figure out how to do this. You'll just go to your math button, and I actually think it's on the main menu. You just have to go all the way down until it says log base, and it will let you type in a base. But if you don't have that, you're going to need to split this up and type it in as the log of A divided by the log of B. This parenthesis is really essential that you put that in. The calculator will open this one, you got to close it. The calculator will open this one, and this one doesn't matter. But you need to tell your calculator where to end that top part. So like this problem is saying 4 to what power is 11? Who knows? Because that's not an even number. So we're going to rewrite this as a log, and it's log base 4. Remember, the power always goes over here, and the number goes here. And so I can ask my calculator to do that. And if I don't have a graphing calculator, I'll do the log of 11, close it out, divide by log 4. And it will kick out my answer. And my answer is going to be about 1.730. So figure out how to get that on your calculator. And then if you did 4 to that power, it won't come out to be perfectly 11 because I rounded off, but it'll come out to be pretty close to 11. So same thing here. You have to have this part alone, and I do. Like you can see down in some of these problems later, there's other stuff going on. But I have the exponential part alone, so I'm going to write that as a log. The base is 8. The power goes over here alone, and then that 915 tucks in here. So I'll ask my calculator to find the log of that 915, close that down, over log 8, because this is saying 8 to what power is 915, and I have no idea. So when I do that, I get approximately 3.279. And if it's a quiz, I can go back up here, put that in as 8 to that power, and see if I come out pretty close to 915. So in this problem, I've got some more to do. This is my power part, my exponential part. I need to get that alone. So I'm going to start by adding the 15 here and here. So now I have the exponential part alone, but it's going to be equal to 38 instead. I'm going to rewrite it. So log base 3, and then that's going to be of my 38 because the x plus 1 is going to go over on the other side. So this I can get on my calculator. I'd have to type it in as the log of 38 divided by the log of 3. You should come up with about 3.311. And then to get your 1 alone, you just have to subtract 1 like you would in algebra 2. Or algebra 1, I mean. You are in algebra 2. And so in the end, I get 2.311-ish. And I can still go back and plug that in up here and do all the math to see if my answer is right, just like you always can with solving. So here the part that I'm going to need alone is this. So I'm going to begin by taking away the 32 so that I can have that part alone, and then I'll be able to use a log to get rid of that. So if I take my 78 and take away the 32, I'm at 46. So log base 2 of that 46, and then the powers alone on the other side. This I type into my calculator. You should come up with about 5.524. Make sure you can do that. Like try it on your own calculator and figure that out. So then to get the to get the x alone, I'm going to add that 6. So I'm coming up with an answer of about 11.524, which I can go in there and try if I want to. So it's just a matter of getting used to the fact that if I have x in the power and I can't find it on my power chart, I'm going to use logs to help. Here I'm taking away the 2. So I have 10 to what power equals 163. So of course I have no idea. Now keep in mind, this would be log base 10 of 163 equals x, but that's the same as just log because that's the common log. So you would literally go to your calculator and type on that log button, log, 163, and it's going to give you an approximate value of 2.212-ish. And I can go check that if I want to. Okay, last one, just straight up calculation. This is the part I need alone, so I have to add a 25 here and here. So I have e to the x plus 7, and then here I'll end up with a 170. Now this is log base e, so this is actually an ln, and then my power is going to always be on the other side, because if I wrote this, this would be log base e, so we just write it as an ln. Again, you can just use your ln button on your calculator. ln 170 will give you about 5.136. And then to get it alone, you're going to need to subtract 7. So I end up with x being about negative 1.864, which is not a problem. I can have a negative power. So I could test it in my equation if I wanted to see. So how does this look in some of the other stuff we've done? We've done some growth, but we've never really had to work backwards. So let's try this one. Polar bear population in the Western Hudson Bay of Canada has been declining at a rate of this. So keep in mind, 1.32% requires us to move that over 2 spots. So the R is going to be 0.0132, and because it's declining, we're going to have 1 minus R. So this is 850. This is our start, and keep in mind then that T is going to be years after 2013. So the model is going to be that my population is that starting number. It's declining by that 0.0132 R value to the T power. Now, you could go ahead and do the 1 minus, which would put you with a B value of 0.9868. If you put this into your calculator, you would get this. And then those are both to the T power, where T is going to represent the years after 2013. So this is was, so this is before, because it says in what year was the population 1,200, meaning there were more. So that's in the past. Keep in mind the past is actually going to have negative time, because you're going to be years before 2013. So I'm going to have 1,200 polar bears, and then I'm going to set that equal to my equation. And I'm looking for time. So this is the exponential part, so I need it alone, but it's currently multiplied by 850, so I'm going to divide out that 850. That is going to land me at 1.412 equals 0.9868 to the T power. So now we know that if something's to a power that we're trying to solve for, we can rewrite it. So this statement would be the log, and then the base is the 0.9868. The power always stands alone, so the 1.412 fits in here. So it's kind of messy numbers, but I'm going to do it the same way. I'm going to go to my calculator and use my change of base to do this, close it down, and then over the log of my base, so the number on the bottom stays on the bottom. And that's going to tell me the time. And I'm getting negative, which I expected, 25.96. So it's approximately 26 years before, because that's why it was negative, our start date of 2013. So if you took away 26 years from that, I'm just going to hog up all the paper. You're going to be back in 1987. And I'm the only human that actually was alive then. So it was a very good year. So that looks like a lot of work, but it's exactly what we've been doing. The only new step is that division at the beginning. Now the next one says, in what year will? So this is going to be in the future, and this is going to be a positive T. Drop to 810. So I'm going to be here at the end of 810, started with 850. My growth factor, which is really a decay factor because it's less than 1, and I'm going to do the exact same math. I need to have this power part alone, so I divide out the 850. When I do that, I'm at 0.9529-ish, and now I'm ready to switch it to a log. So the log has a base of 0.9868, because that is the base thing raised to the power. Power goes by itself over on the right, and then this guy goes in here. So when I go to write that into my calculator, or type that in, I have that log of the top number, shut that down, and then over the log of that base value. When I do that, I get t is going to equal 3.6, and that's going to be years after 2013. So basically in that fourth year, so it would be during the year 2017 that population dropped to 810. So don't let those last two freak you out, because you're really just doing the same exact math, getting the exponent alone, rewriting it as a log, putting it in your calculator. It just feels different because the numbers are so messy. So hopefully that helps you. Bye, guys.